Hey everybody, it's Mrs. C and I'm coming to you with a piggyback lesson. The last one I just posted was on writing equations parallel, and now we're going to jump right into writing equations that are perpendicular. And I have to say, if you understood how to write the equations that were parallel, you are going to have no problem writing equations that are perpendicular, because it's exactly the same with just the tiniest little flip twist. And once you remember to do it, you can, just condition yourself to do it. Excuse me, just adjusting myself for a second. It's a no-brainer as long as you can follow along with the parallel. Like I said, it does take a little getting used to. Nothing is easy that is done right and done properly. So let's just jump into it. We've got the equation y is equal to a negative 2/3 x plus 2, and let's start there. That's a horrible color to start with. I can't see a thing. Y is equal to a negative 2/3 x plus 2. And I'm passing through. I've done this problem so many times, I think I've almost got it memorized. Yes, I do have it memorized. And it's passing through 6, negative 5. Double checking. Yes, I'm right. Okay. Now, before when we did in the last video, if you didn't watch the last video, what are you missing? Come on, go watch that video. Because I did a brief intuition on what the line looks like and what it is we're being asked to do. In this case, we're being asked to find the slope that is perpendicular to negative 2/3 x plus 2. And in the last video, I graphed this very equation. So let's do it again. It's passing through, we'll call this 2, okay? It's passing through 2 because that's the y-intercept, and it has a rise-run ratio of negative 2 to 3, which brought us somewhere, if this is 3, brought us somewhere around here, okay? So this program does not do lines very well, I'm just going to tell you. Okay, I'm trying. Oh gosh, hang on. Not very good, but you know what I'm getting at, right? Okay, and it's kind of important in my opinion to do it this way, even though I'm not really hitting that 2 perfectly. The 2's not in a perfect space anyway. So what we're trying to do is write the equation that's perpendicular to this line. Do you understand? Now perpendicular lines form 90-degree angles. So that's pretty easy to judge. The line's got to do, let's do a different color. Line's got to do what a line's got to do. This line's got to go like that, right? And it's got to form a 90-degree angle. But the question is it going to be up here? Is it going to be down here? Because all of these form 90-degree angles on the yellow line. It's a matter of where does it hit? It's got to hit a point, and it's got to hit at 6, negative 5. So it's got to be perpendicular and hit at at 6, negative 5. So let's just put a point at where 6, negative 5 is, okay? So 6, negative 5, say, is somewhere here. It doesn't like that. Just throwing it down for you. So if that is true, and that's where the point 6, negative 5 is, then what we also understand is that this line then has to do this. Now we know that the line we're searching for is the line that will hit that point and form a 90-degree angle with the yellow line. That's all we're doing. And so, for all the good that that'll do you, I think you can see that at least the B, when we figure out what the B is to this equation, the B gonna be way down there. Because even when I sketch this, look how far my line isn't hitting. It's going to be way down. So if I have a little intuition as to what I'm expecting, then when I get it, I'll have an idea whether I'm right or wrong. Now, I just went and erased this, and I think I didn't want to. I'm going to put it back. Can you take a look at the blue line for me? Let me get rid of the extra blue line that I don't want you looking at. Yes, that blue line. Thank you. Okay. What could you tell me about, just when you look at it, about the slope of the blue line? Okay, you see? It's going in the opposite direction. All perpendicular lines have opposite slopes. They have to. That's the only way they'll ever cross each other at a 90-degree angle, is if their rise-run ratio are opposite signs. So one's a positive, then the other one crosses in the other direction and is a negative. So to find a perpendicular slope, if you have the slope, your perpendicular slope, and I'm off the edge, your perpendicular slope has to be the opposite sign. And in this case, that would be positive. This line is going up. Now, the next thing is not only it's not good enough to be positive, it has to be the opposite reciprocal. So its opposite would be the fact that this one is negative, so the perpendicular has to be positive, but you also have to have the reciprocal or the flip. I don't like to say it flipping the fraction, but fine. If you know what I'm talking about, then call it flipping. You have to have the opposite and you have to flip it. You need the reciprocal of it. So we must remember to do that, because if we don't, it's just not going to work out. Not going to get a perpendicular slope. Okay. Let's get going, because the hardest part is pretty much done. My slope that is perpendicular to the equation that's given is going to be a positive 3/2. Done. Now, given point slope form, all I need to do is plug in the new slope. Don't plug in the old one. I've done that 1,000 times when I wasn't thinking, and you get a parallel line. Into the y minus y1 equals m times x minus x1 formula. That's the point slope formula for those of you who didn't watch the video before this. So we plug in the new slope, which is 3/2. That would go here. And then we plug in the xy pairing, which is a 6 back here and a -5 up here. And then we evaluate and we get y plus 5 equals 3/2 x. And that's a -9. I'm doing this math here and here. I'm multiplying 3/2 times 6 over 1, 2 into 2, 1, 2 into that, and 3 is 9. So we did that in our head or off to the side. If you're not great with fractions, I would recommend doing the math out to the side. And then what I'm going to do is I'm going to continue on. I'm already feeling good, because when I minus the 5, I have exactly what I thought was going to happen. I'm going to have a B, or a y-intercept, that is much further down than my original picture I couldn't show. So I'll make that in English in a second. -14. This is my slope-intercept. Y equals 3/2 x minus 14. And if you recall, when I had drawn it, my line was going like this. And I couldn't even see where I was going to hit the y. And that's because I was going to hit way down at -14. So in my mind, that makes sense. So I have y is equal to 3/2 x minus 14. Okay, so y is equal to 3/2 x minus 14 is my slope-intercept form. And now, as you recall, we've got to write it in standard form. And so I'm going to erase all this other stuff so that I can rework this form. So currently I have y equals 3/2 x minus 14, and I want to write that in standard form. So the first thing I want to do, it's a personal preference, but the first thing I like to do is to get rid of any fractions. I'm not allowed to have them in my standard form, so I'm going to multiply both sides by 2, and then I'll get a 2y equals 3x minus 28, and then all I need to do is move my 3x over. Now I have a -3x plus 2y equals -28, and a quick little fixie fix on my signs, and I wind up with the final answer of 3x minus 2y equals 28. So I have 3x minus 2y equals 28. I'm going back over to double check that. 3x minus 2y equals positive 28. Yep, that's what I wrote. That is the standard form of the equation that we got in point slope, then slope intercept, and then finally standard form. So let's do this next one. We have y is equal to 3x minus 7. We have to pass through negative 9, 2, and we got to be perpendicular. So you go ahead and copy that, and I'm going to answer the phone. Hold, please. Okay, I'm back. It was a telemarketer. Go figure. All right, so here's what we have. We have y, I'm just copying from this. Y is equal to 3x minus 7. That's the original equation. I'm being asked to write the line that is perpendicular and passes through negative 9, 2. So I don't really know why I wrote slope perpendicular. I guess I was overthinking it. Okay, so I'm going to write the line that's perpendicular, and it passes through negative 9, 2. So if I know that the slope of the given line, sorry about that. If I know that the slope of the given line is 3, and a perpendicular slope has to be opposite reciprocal, then I have to be, first of all, negative, and second of all, not 3 over 1, but 1 over 3. And that, guys, that's the hard part. That's what differentiates it from being parallel. Everything else is the same. It's just that with perpendicular, you need to remember to take the opposite reciprocal. And if at all possible, just look at the thing once you get it in slope intercept on a graphing calculator, and it's going to show you pretty much whether it's perpendicular or not. I mean, you'll look at it and you'll go, oh yeah, okay, that kind of looks like it. Or, whoa, that doesn't look perpendicular, and then maybe you forgot to take the opposite sign, or maybe you forgot to take the reciprocal. All right, so do it the exact same way. Why? Everything starts with the point slope form, guys. Always goes back to your form and to just fill everything into the proper form. So we have the y minus y1 equals m times the quantity of x minus x1. I always have students ask me, Mrs. C, how do you remember all of these forms and these formulas? Easy. That's the easiest thing to do. You write it 1,000 times, and by like the 1,000th, you memorize it. And that's what I would say to you. If you're having trouble with your forms and your teachers don't, your teacher's probably me, but say, for example, I was like a huge YouTube hit and I have people from all over the country watching my videos, then I would say to them, if your teacher doesn't tell you what your forms are, then you need to write the form every single time you do the problem. No shortcuts, and you will wind up memorizing the form. That's my advice to all you out there that are not my students, which we all know is nobody. But anyway, let's fill in the formula. So my y1 is going to be 2. My x1 is going to be a negative 9. So there's that double sign, make it a positive. And my slope is, I already wrote it down, a negative 1/3. I always like to do this. I don't like to take the opposite reciprocal from here, because then I have a tendency to forget to do something, and that's where my mistakes come from. So I'll rewrite y minus 2 equals a negative 1/3 times the quantity of x plus 9. And guys, just for the sake of saying it, this is point slope form. This is if you had an assessment and they asked you to write the equation in point slope form, this would be what you would write. Y minus 2 equals negative 1/3 times the quantity of x plus 9. But usually they say to go a step further, so that's why I'm not even identifying that form. That's the form for point slope once you plug in, and I like to take care of the double signs. I've seen teachers' manuals that don't even take care of that double sign. They write minus and negative. Yeah, they do. Okay, so let's just quickly evaluate. We're going to put it into slope intercept first. So y minus 2 equals a negative 1/3 x. And here's your little off to the side multiplication. If you can't do it, you would say, first of all, sign negative times positive negative. And then the math, 1/3 times 9. Over 1, 1/3, the answer's 3. Don't feel bad about going off to the side and doing the calculation and not doing it in your head. So many people feel like they need to do that step in their head. That's silly. No, you don't. So add 2 to both sides, and you're done. So I just need to, the hard part is finding a place to write it. Y equals, what do we have? A negative 1/3 x, and a negative 3 and a positive 2 is a negative 1. There's slope-intercept. So let's write that. Y equals a negative 1/3 x minus 1. Y equals a negative 1/3 x minus 1. Please, please, people out there, my peeps, if I copy any of these problems wrong or make a mistake, will you let me know? I'd really appreciate it. Standard form. All right. Wow. Where do we find room? We don't. We have to erase. I'm just erasing all of this. It's just too much going on. Pretty with the yellow and the blue, though, I have to say. Okay. Okay. Here it is. Woohoo. All right. We have, I'm just going to write it up at the top. Y equals a negative 1/3 x minus 1. And we've got to put this baby into standard form. And we got all kinds of problems. We've got fractions, first of all. Let's start there. Get rid of the fraction. How do you get rid of a fraction? You multiply by the denominator. Very good. So we wind up with a 3y equals a negative 1. If you want to write negative 1x, my students really like to write negative 1x, so go ahead. You can write negative x as well. Minus 3, we did the distributive property to both. And then go ahead and get the 1 over, add 1x. Add 1x. How nice. It becomes positive. I don't have to deal with any issues. I've got a 1x plus 3y equals a negative 3. And most people who know me know I don't write a 1. I just write the x. That's standard form. X plus 3y equals negative 3. X plus 3y equals a negative 3. Just for the sake of argument, a lot of people say, but I thought you said you can't have a negative. I said the x term can't be negative. Don't misquote me. That's all I got to say. All right. If you have to have negatives. If you've got a negative, somebody's got to be negative. You can't get rid of the negative. All right, guys, that's that. Now, on my next video, I'm going to address these special cases for both the perpendicular and also we had the parallel issues. And I will be going over that on the next video, just the special cases. They're so easy. Oh my gosh, they're so easy, but they are confusing if you don't know what you're doing. You don't have intuition as to what you're doing. They are confusing because they don't quite follow the model because they're that easy. It's so easy. You don't need a special model. You just need intuition. So that's what we'll go over in the next video. It's been a blast, guys. I'll see you on the flip side. Peace.